Have you ever wondered about the intricate science behind a classic pendulum clock? Today, we'll delve into its surprising physics. From grandfather clocks to scientific instruments, pendulum clocks have a rich history. But what exactly are they, and how do they work? A pendulum clock uses a swinging weight, or pendulum, as its timekeeping element. Its consistent swing ensures accurate time. At its core, the pendulum swings back and forth, powering a series of gears that move the clock's hands, marking the passage of time. Gravity is the unseen force that makes a pendulum swing. Without it, the clock simply wouldn't work. Gravity provides a constant downward pull, which, combined with the pendulum's design, creates its rhythmic oscillation. As the pendulum swings up, gravity slows it down, then pulls it back down, gaining speed until it reaches the lowest point, and then the cycle repeats. One of the most fascinating aspects of pendulums is, quote, isochronism. This principle is crucial for accurate timekeeping. Isochronism means that a pendulum's swing period is nearly independent of its amplitude, or how wide it swings. A small swing takes almost the same time as a large one. This property makes pendulums excellent timekeepers because minor variations in their swing don't significantly affect their accuracy. The escapement mechanism is vital. It gives the pendulum a tiny push to maintain its swing and releases the gear train one tooth at a time, regulating the clock's movement. While isochronism is powerful, other factors can influence a pendulum's accuracy. Let's explore some of these. The most significant factor is the pendulum's length. A longer pendulum has a slower swing period, and a shorter one swings faster. While isochronism helps, very large or very small amplitudes can slightly affect the period. Precise clocks aim for consistent, moderate swings. These environmental factors might seem minor, but they play a crucial role in a pendulum clock's long-term accuracy. Temperature changes can cause the pendulum rod to expand or contract, slightly altering its length and thus affecting the swing period. Air resistance and friction, though small, continuously sap energy from the pendulum. Clockmakers design mechanisms to minimize these effects, like using low-friction materials and airtight cases. Despite these challenges, pendulum clocks achieved remarkable precision for their era, a testament to ingenious engineering. The inherent stability of the pendulum's swing, combined with clever compensation mechanisms, made these clocks the gold standard for timekeeping for centuries. Pendulum clocks revolutionized navigation, astronomy, and daily life, underpinning scientific and industrial progress. The pendulum clock, a marvel of physics and engineering, continues to fascinate. Its legacy endures, reminding us of the elegance of simple, fundamental principles in action.